In other segments, I've talked about field research and I've talked about lab research. Basically, you can view field and lab research as occupying opposite ends of a continuum based upon the amount of control that the investigator has over the actual situation in which the observations or experiments are taking place. And so you can view it this way. You should not view these distinctions as necessarily mutually exclusive, especially the points along the continuum, because there can be crossover elements in between some of them. But of course, the field would be the least amount of environmental control, and the lab would be the most amount of environmental control. Certainly not total, but an awful lot more than the field. Now, if we look at this continuum, there are points in between: unobtrusive field observations, obtrusive field observations, semi-free field observations, observations in captivity, and then complete environmental control. So let's look at each of these with some examples, starting with unobtrusive field observations. So the whole idea here is for the observer to remain as inconspicuous as possible. So whatever it is you're observing doesn't know that you're even there. And so we would use blinds, and I've given an example of some blinds in a different segment. There's a trick, by the way. It's going to totally depend on what species you're working with. But if you're not camped out in the blind all the time, you can try this trick. Some people call it the 2 enter 1 leaves trick. So you might go into your blind very, very early in the morning. Well, bring somebody with you. And then both of you stay in the blind for about 5-10 minutes. Send your friend away. Your friend can go back home and catch up on some sleep. You stay in the blind, and as long as you're quiet, whatever it is you're observing might think, quote unquote, that nobody is there because they've seen somebody leave. Now, there's good evidence that some animals can indeed count, but I think that's kind of limited in terms of which species actually can do that. So basically, the idea is, although 2 people are entering, 1 person is leaving, as far as they're concerned, both people are leaving. So that sometimes works. Here's a good example of unobtrusive field observations. So this is where grebes nest. It's a very difficult area to try to get close to them. Plus, they don't really like people to be close to them, especially while they're nesting. And so here we have a nesting grebe off in these reeds over there, sitting on a nest. And what this investigator did, by the way, that's not the investigator, but I needed a picture of a big inner tube. So actually, this is a tire, not the inner tube, but you get the general idea. So the researcher actually got a huge inner tube, like one that would come from a huge trunk, and of course inflated it and built a wire frame over it, and then just draped it with vegetation from around the area where the grebe was nesting. And so each day he would swim into it from behind, so it's the opposite side from where the grebe was, pop up in the middle of it, and slowly every day, maybe just very slowly, move it a couple feet closer to the nest. I think he did this over a 2-week period because, again, if the grebe senses that somebody's around, it could abandon the nest altogether. So this is a photo that he took from inside the inner tube, and it worked. He got very close to the nesting grebe. He was interested in looking at how they interact with their offspring, got some magnificent photographs. It would be next to impossible to get a photograph or a movie like that without using this sort of technique. Okay, the next point along the continuum is what we call obtrusive field observations. There are situations where you simply cannot remain hidden from whatever it is you're observing. So you have to be now as obtrusive as possible and hope that your subjects get used to your presence. Again, it's going to totally depend on what species you're looking at. So in sociology, actually, this is called the participant observer technique, which operationally defines what we mean by obtrusive field observations. You are observing the organisms while you are a participant among them. You're part of their group. So that's basically what I said before. You accustom your subjects to your presence while you're interacting with them and making your observations. And that's exactly what this scientist is doing. Here's some pretty interesting examples of this.
After spending nearly a decade observing this troop, Chadden has gained their trust, and he can move among them at will.
This is morning chill-out time. It might look just like this mass of monkeys, but in here we have individual family groups, and these females pick and choose a male. What I want to do is try and get clear pictures of these males so I can compare the different qualities of that chest patch and see if I can get to the bottom of whether the females are using that to choose their males.
The first step is to create a digital catalog of the male's chest patch colors, photographing them next to a standard color chart for a controlled comparison.
Paparazzi time. Nice chest. Oh, lovely. Oh, out of the way.
Chadden is amassing a large collection of gelada portraits.
Oh, sweet.
With chest patches in a range of shades.
Oh, good. Good boy.
This little guy's too young to make the cut.
I wonder how you're going to impress the girls, huh? How are you going to get selected?
At the end of the day, Chadden can download his photos to a laptop to be sorted by color and by mating success. He knows these males well, and he knows how each one rates with the females.
You see the little dots I'm putting on his chest? As I move the circle around, all the ratings down the side change.
It's clear that family males like Chewbacca and prime bachelors like Elvis have the reddest chest patches. Chadden's theory could be correct. Females may be looking for the right color when they choose a mate.
Here's another example.
Lazuli clan was the first group that we habituated, and we've been with them for 6 years now. So virtually all these animals are very, very well used to us. In fact, for almost all these animals have been born in the clan, and one of the first things they'd have seen when they came out of the burrow for the first time is us. So they now regard us as quite part of the environment.
The researchers want to comprehend the meerkats. They're studying the animal's copious vocalizations. So they need to spend a lot of quality time ingratiating themselves into the group.
I think if I were you, I'd wear a hat more often.
Certainly would help against the fleas.
Well, that's about as obtrusive as you can possibly get. Okay, the next point along our continuum is semi-free field observations, where there is some degree of confinement. There is some kind of an enclosure, but it's so large that it probably doesn't matter all that much. And a good example of this is Cayo Santiago Island, which is just off the coast of Puerto Rico. And years ago, decades ago, it might have even been back in the 1920s, I forgot when, they established a rhesus monkey research station on this island, and basically all these monkeys have been roaming free on the island ever since. It's not that big an island, and there's a research facility there, and primatologists and ethologists have been there making numerous observations of primate behavior in what is as close to a wild state as you could get, but remembering that they can't get off the island. They're not going to swim the distance to shore. They're just not going to do that. So there is some degree of confinement. And so over here we can see a view of the island, and there is a rhesus monkey on the shore. Another example of semi-free would be one of the very large zoological parks, not like a small cage zoo, but something more like this, where there's huge open spaces where the animals can roam around. Obviously, they can't get out, but nonetheless, there is some degree of confinement. Finally, no, not finally, next to finally, observations in captivity. That would be more like a conventional cage type zoo. So, these are small enclosures. So now you got to start worrying a little bit more about external validity or generalizability, which I mentioned in another segment, because there's a possibility that there might be more artifacts because of the very artificial situations that we find in these zoos. Large aviaries would also qualify. I'll show you what I mean by that in a moment. But again, you do have to be careful about your observations, and you'll recall from another segment how Solly Zuckerman's observations, which were made only on rhesus monkeys in the London Zoo, did not in fact generalize to the way that they behaved in the field. This is an aviary. This is in the town of Walsrode in Germany. This is, I think, the largest aviary that I've ever been in. It's about, 3 or 4 city blocks long. Really, really huge. And there it is down there. And there's actually a functional seashore. I've never seen that in any other aviary that I've been in this country. I've been to a number of them. In this country, you'll find them in some of the larger zoos. There's one in Busch Gardens in Tampa. I've been to that one as well. But this one's really amazing. So that's inside Walsrode. And there's a wave generating machine to actually simulate what would happen on a beach. So they have shorebirds in there. And, it's like they're right there on the ocean. And these are just some highly edited clips taken from inside Walsrode Aviary. So you can see it's quite large. Birds are just flying around freely as people walk through. Taking care not to get pooped on, of course. So the captive element is obviously apparent. They can't fly out, but it's still a fairly large open space. But because, that the screen is right there, I would make this more akin to observations in captivity rather than semi-free. But there's still an obvious element of semi-freeness to an environment like this. Now finally, we have complete environmental control, a typical laboratory situation. That happens to be a radial arm maze over on the left, and of course cages for rodents. There are some situations where you really can't do observations in the wild, and a good case in point is with Siamese fighting fish, which are found in the Amazon River. It's pretty murky down there, and if you really want to see what's going on close up, it would be really, really difficult to do so. So, now you have to rely more on an indoor aquarium and hope that what you're seeing is in fact real. Now, one interesting aspect of parental behavior in Siamese fighting fish is that the male takes care of the eggs. Now, in this species, the eggs actually float to the surface. So, those are eggs over there. And what happens is that the male oxygenates them, keeps the embryos alive by blowing air bubbles around the eggs, as we see here. Now, this was obviously made in an aquarium. Couldn't have gotten those shots in the Amazon River. And again, some very close-up shots that could only be made in captivity. Again, you got to be a little bit careful about possible artifacts. And of course, people that study controlled conditions of birdsong, where you're recording song, you're making various manipulations on the birds, giving them playback experiments and things like that, will often use cages like these. These compartments were where I was for some time at the University of Bielefeld in Germany. And basically, it's one of many situations where people are working in laboratory-type environments. So we have this continuum from field to lab with many points in between.